Hello, and welcome to the Key Stage 4 chemistry topic, finite and renewable resources. Before we get started, can you please make sure you have a pen, paper, pencil, ruler, and a highlighter or another coloured pen or pencil for self-assessment. And can you also make sure you're in a quiet room, quiet space with the correct equipment and with no technology to distract you so you can entirely focus on this recording. Can you pause the video for 10 seconds and get down the learning objective to understand how chemists have tried to solve the issue of finite resources? Okay, your retrieval practice is on the screen now, guys. There are 3 questions. It's going to give yourself 4 minutes to have a go at them. So 4 minutes, go. So, your 4 minutes up there, guys. Can you please make sure you've got another coloured pen or pencil, and we'll self-assess these now. Question 1 just asks, list 2 common resources that are used for following the things. So warmth, shelter, food and transport. 1 in modern life and 1 from ancient history, not used so much anymore. So for warmth, we have polyester and wool. So wool being the older one from history, from sheep. For shelter, it's concrete, used in houses and buildings, tower blocks, and timber, which is just wood. Food, we have plants, we used more commonly now, but then animals used to be hunter-gatherer society. And then transport, oil, petrol for diesel and cars, and then animals, obviously there's a horse and carriage from history, which is not used as much anymore. So give yourself a mark out of 4 for those 4. Question 2, describe the difference between older resources and more modern resources. Well, to put it simply, older resources are normally smaller scale and hard to produce in big quantities. Modern resources are normally on a much larger scale and can be made in batch products and easier to produce in large quantities. So that's the difference between them there. And question 3, to explain why the types of resources have had to change over time. To put simply, because of the dramatic exponential increase in population, the human population, this has had an impact massively, meaning much more large-scale resources have been required for warmth, shelter, food and transport for an ever-increasing population. So the population, with an ever-increasing population means an ever-increasing demand, so the production of resources must increase dramatically as well. So give yourself a mark for those there. So 4 and 1 and 1. So give yourself a mark out of 6. Excellent if you got 6. Well done if you got 5. Good if you got 4. 3 and below. Add in the corrections there. So what this recording is all about today, it's all about the learning outcomes are to describe the uses of some finite resources, going to understand what finite means and their possible alternatives, and then compare data using standard form and orders of magnitude. Okay, so our first task, what I want you to do is to look at the type of graph here and compare and describe, using the data from the graph, what has happened in the last 30 years to natural fibers and synthetic fibers. So you're going to have to compare the data between the two using the key to answer these questions. And then, as an extension, so once you finish that, as an extension, explain the trend you've identified above using the information in the table to justify your reason. So using the information in the table here. So this is the extended question, guys. I'm going to give you 10 minutes for this. This is a 10-minute task. Can you pause the recording for 10 minutes? Have a go. Please make sure you're using full structured sentences and have a go. So pause the video, 10 minutes, go. Okay, your time's up there, guys. That's 10 minutes over. Can you make sure you got another pen to self-assess this, and we'll go through it now. So the first question is just coming up now. Describing the data using data from the graph. What has happened in the last 30 years to the natural fibers? Their use has stayed roughly constant, so the constant of 20,000 to 30,000 million tons per year. Synthetic fibers, however, has increased dramatically from around 15,000 million tons to 70,000 tons per year. So that's the increase between. So natural fibers stayed at roughly constant. Synthetic fibers increased with those numbers there. Give yourself a mark out, for that out of 2. And then as an extension, hopefully you got that because the population has increased a lot in the last 30 years, the amount of fibers needed has also increased because of the increased demand. As synthetic fibers are easily produced in large quantities and very cheap, as they are identified in the table, the majority of new fibers have been synthetic or man-made. That's what synthetic means. So give yourself a mark out of 4 overall for those 2 questions. Excellent if you got 4. Well done if you got 3. 2 and below, just add in the corrections there and improving that for next time. Okay, so what does finite mean? So finite versus renewable. So some materials are finite. You may have heard this before. This means they will run out. There is only a limited amount of that available. Common examples being crude oil found deep in the ocean, which is only a finite amount, or natural gas. But some materials are renewable. This means they can be replaced as quickly as use them. So using solar energy, using the light for solar energy, wind, and using the tidal waves for tidal power as well. And third key point, sustainability is important to maintain resources for future generations. So sustainability just means to use what we have according to our needs and not our wants, and so then it can be used in future generations. So your next task, what I want you to do, there's going to be 6 different hexagons that come up. 1 has already been filled in, and you need to just label each one. So you need to just write in each hexagon, label which one is that you think is finite or renewable, and give a reason why. So justify your decision. 1 has been done as an example. So my example is coal. It is a finite resource. So coal used to be used in coal-powered trains. It's a finite resource, so there is only a limited amount. This is because it takes millions of years to form, but humans use it. We use it very, very quickly. It can be burned and combusted very quickly. And there are 5 other examples that I want you to complete. So cattle, wheat, iron, wind, and plastic. Tell me if it's a finite or renewable resource and justify your decision. I'll give you 7 minutes for this. So 7 minutes. Please have a go. 7 minutes. Go. So your 7 minutes up there, guys. You make sure you've got another coloured pen and pencil to self-assess them. The answers will come up on the next slide. Can you pause recording for a required amount of time to add in any corrections and give yourself a mark out of 5 this time? So the answers come up just now. Okay, so just a few quick questions. What I want to do is just pause the video and have a go at this question. So what is the difference between synthetic and materials? So have a think, give yourselves 30 seconds, and do you think it's A, B, C, or D? Okay, your time is up there, guys. So 30 seconds just gone. It is, of course, C. Synthetic materials are man-made and natural is just found in nature. Synthetic, keyword there, is man-made. So correct answer being C. Well done if you got C there, guys. Excellent work. Another quick question. So why was the use of synthetic materials increased over the last 100 years? So 30 seconds, A, B, C. Which one do you think it is? 30 seconds. Okay, the correct answer is, of course, A. They're easy to produce in mass and they last longer as well. Compared to natural materials, they last a lot longer. They're more durable and more used to wear and tear and can be more resistant over longer periods of time. Third question, what is a renewable resource? So same again, 30 seconds, A, B, C, go. Correct. The answer is B, a resource we can replace quickly as quickly as it is used. So it's instantaneous in replenishing the supplies of a renewable resource. And question 4, why is sustainability important? A, B, or C? Excellent. The correct answer is, of course, B, to ensure future generations have enough resources to make sure resources are used fruitfully, wisely, and for future generations to use as well. So we're now going to move on to comparing numerical data. So sometimes we compare numerical data. I just want you to have a think as we're going through the next few slides in the recording, what difficulties may occur when comparing numerical data from different sources, different types of data. What difficulties can be overcome by that? So numbers which are very small or large can be hard to work with and can seem meaningless or even hard to comprehend and compare. So there's two different forms that can be made useful, standard form and orders of magnitude. So positive powers of 10, so 10 over the power of 1. Hopefully you know that this is 10, so 10 to the power of 1, it's just 1 of itself. 10 to the power of 3 is 1,000. 10 to the power of minus 3 is 0.01. That is standard form, simply just there. Now, standard form can be used as a common GCSE exam question, not only in maths but in science, and it's common used to quantify lots and lots of numbers together. So what I want to do is just write the full number of the standard form number here. So 1.15 times 10 to the power of 2. What is that in its decimal form? So 30 seconds, have a go now. Okay, hopefully you got this, guys. It is 115 because it's 10 times 10 to the power of 2. 115, excellent if you got that. Same again for this question, guys. Pause the video for 30 seconds and have a go. Okay, so hopefully you understood that the diameter of the Earth in its decimal form is 12 million meters. 12 million meters. Okay. And then one more, last one. What is the diameter of a human cheek cell in its standard form now this time? So we've been given the decimal. What is it in its standard form now? Okay, so hopefully its standard form is 5 times 10 to the power of minus 6. Remember, if it's 0 point something, it's in the minuses. So it's 5 times 10 to the power of minus 6. Okay, so that overviews standard form quickly there, guys. Now what we're going to focus on, the final part of this recording is on orders of magnitude. So it allows us to compare very large and very small values to each other and compare them between them. Can you just have a read through this? So pause and read through the remaining 2 paragraphs. Can you do the same again? Can you pause and read through this slide here? And finally, just pause the screen recording and read through the final slide here. Okay, we'll move on to the final task now, the plenary task. This is the final task. What I want to do is compare, using that information you have just read there in this plenary, compare the following and give yourself 5 minutes for this, 5 minutes, and then we'll go through it and self-assess it. So 5 minutes, go. Okay, time's up there, guys. 5 minutes is up there. We're going to self-assess it now. Can you add in the correct answers or give yourself a tick and mark out of 5 just here? So 1,000, 10,000, 10,000 again, 10, and 100. Just give yourself a mark out of 5 there. Excellent if you got 5. Well done if you got 4. 3, good. 2 and below. Add in the corrections just there. That concludes this video, guys. Thank you for listening. Take care.